Hi everyone, this is Dr. Nak, and we are going to go over section 8.1, the inverse sine, cosine, and tangent functions. Let's just review a little bit. So recall that the domain and the range, and then f goes from the domain to range, and then f inverse will go the other way around. And the property was f inverse of f of x equals to x for all x in the domain of f, and f of f inverse of x equals to x for all x in the domain of f inverse. If you look at the picture, domain of f is the range of f inverse, and the range of f is same thing as the domain of f inverse. And the graph of f and f inverse are the reflection of one another about the line y equals to x. And if y equals f of x has an inverse, then the implicit equation of the inverse function is x equals f of y. If we solve this equation for y, we can get the explicit equation y equals f inverse of x. So to find the inverse function given a function, you're going to have to replace your y with x and then x with y, and you're basically trying to solve for y. And if you can express y equals everything in terms of x, then that function becomes the f inverse of x. And also remember that in order for the f inverse to exist, the given function f of x must be one-to-one function, which means that it's going to pass the horizontal line test. So let's just look at the inverse sine function. So what I did was I drew the graph of sine of x, and notice that f is 1-to-1 on the interval from negative pi over 2 to pi over 2. Of course, it is 1-to-1 from pi over 2 to 3 pi over 2, but we're going to take the piece of the graph that's closest to the origin. All right, so y equals sine of x. Domain of sine of x is all real numbers, and the range is from negative 1-to-1. And please note that domain of y equals sine of x is now restricted in negative pi over 2 to pi over 2. So that means that f inverse exists on that interval. Now, how do you draw the sine inverse of x? You're going to have to reflect that pink part of the graph along the line of y equals to x. And notice that if f of x touches pi over 2, 1, then f inverse is going to assume 1, pi over 2. I don't know if you remember that property or not. So in order for us to graph f inverse, in this case sine inverse of x, what we need to do is plot the points 1, negative pi over 2 and 1, pi over 2. So the graph should look like this. Y equals sine inverse of x. Oh, by the way, the terminology here. We call it sine inverse of x, but other textbook will say arc sine of x. That means the same thing. Arc sine, sine inverse, they mean the same thing. Okay, so try to memorize that graph. If not, you already know what the sine function looks like. So just reflect that about the axis y equals to x. Okay, so let's go with the notation. This is kind of common, believe it or not. All right, inverse sine function is written as f inverse of x equals sine inverse of x. And please note that sine inverse of x, that's just the notation. So that does not equal to 1 over sine x, which what's 1 over sine x is cosecant of x. So definitely cosecant of x, that's not equal to sine inverse of x. All right, so the next one, please memorize that property. That's very important. Y equals sine inverse of x means x equals sine of y. So basically what we're doing is composing both sides with sine of x. So basically sine of y equals sine of sine inverse of x, and sine inverse sort of cancels each other out, so we get x equals sine of y, where x is between negative 1 and 1, and y better be between negative pi over 2 and pi over 2. Okay, let's do some examples. Example 1, find the exact value. So let's call this one A, sine inverse of -1. Okay, so first step, always let theta equals sine inverse of -1. Okay, so let's just try to digest what this means. Then do you see that then theta is the angle between -pi/2 to pi/2 whose sine equals -1. Okay, so let me just write that out. So that means what? Sine of theta equals to -1. So I'm going to say then theta is the angle between -pi/2 to pi/2 whose sine equals -1. Okay, so if you have memorized the sine graph, I think you're good to go. So here's -pi/2, this is pi/2. Now sine is 1 to 1 from -pi/2 to pi/2, so it's going to look something like this. And of course, here is 1, and y value here is -1. Alright, so let's find that angle theta. Sine of theta equals to -1 at where? When theta equals to -pi/2. So, therefore, our answer is going to be theta equals -pi/2. Which means that, well, our theta was exactly sine inverse of -1. So therefore, the exact value for sine inverse of -1 is -pi/2. And that's going to be our final answer. Okay, let's take a look at another example. So let's call this one B. Sine inverse of -√3/2. Okay, so first step, always let theta be sine inverse of √3/2. Now it might help you if you have memorized this already, so let me just recall. Let's go with 30 degrees, 45 degrees, and then 60 degrees. You guys remember what happens? All the denominators are going to be 2's, and sine's going to start from square root of 1, which is 1, square root of 2, and then square root of 3. So do you see what's going to happen? Our theta is looking like our reference angle is going to be pi/3. But let's just work it out. Okay, so first step, let theta be sine inverse of -√3/2. So that implies that sine of theta is -√3/2, where theta better be between -pi/2 and pi/2. All right. So let's analyze a little bit. Let me just draw the positive quadrant. All students take calculus. Now, -pi/2 to pi/2, theta better be between that. So here's -pi/2, pi/2. So your theta better lie between in here, which means what? Quadrant 1 and quadrant 2. Okay, now, sine is negative, so that means what then? In quad 1, everything is positive, so sine is negative in quadrant 4. Okay, so let me just circle that. So your angle is going to be inside of quadrant 4. Our theta better be in quad 4. Now, to find that theta value, there are a couple ways that we can do. Let me just show you both ways because I'm not quite sure which method that you like better. So one of the way is to use the 30, 60, 90 triangle. And then another way is to use A, B, and then R. So let me just first start out with method 1. Use 30, 60, 90 triangle and its reference angle. Alright, so let me just draw that triangle real quick. So this is 60 degrees, so which is pi over 3. And then this will be pi over 6, which is 30. Okay, and the length were 1, root 3, and then 2. Now note that sine of theta was opposite over hypotenuse, but this was, well, I know that it's going to be negative, but we're just looking for the reference angle, so let's just deal with positive root 3 over 2. So which angle has the opposite side of root 3 and then hypotenuse is 2? The theta better be pi over 3. So that implies that theta is pi over 3. So this is your reference angle. Alright, and then notice that our theta must lie in quadrant 4. So from the initial side, let me just draw you a picture again. So we know that your theta better be in quad 4. Okay, so here's the initial side. Now, the reference angle tells you that you need to revolve pi over 3, which is 60 degrees, from the initial side into the quadrant 4. So maybe this will be it. So from to here is going to be the answer. So in this case, since reference angle is pi over 3, you have revolved pi over 3 clockwise. So this angle right here is going to be negative pi over 3. So therefore, our answer is going to be sine inverse of negative root 3 over 2. This was our theta. We call that one theta. So the answer is going to be negative pi over 3. Happened. Okay, now let's do the same problem by using a different method. So I'm going to call this method 2. So instead of a triangle, we're going to be using the definition sine of theta, that's a sine, of theta equals b over r. And then any point on the circle is denoted by a comma b. Okay, so the starting is exactly the same. So I'm going to start out with let theta equals sine inverse of negative square root of 3 over 2. So that implies that sine of theta is going to be negative square root of 3 over 2, where theta is between negative pi over 2 to pi over 2. Now, if you're going to use this method, notice that sine is b over r. Now, r is the radius, so the r must be the positive one, and then b has to be negative square root of 3 then. All right, so note, let me just change the color. So note that in this case, our b is negative square root of 3, and then r is 2. We still need to find a. So let's use the formula r squared equals a squared plus b squared. So this is 4 equals a squared plus 3. So that implies that a squared is 1. So that implies that a is plus or minus square root of 1, which is just 1. Okay, but the thing is, remember, theta must be in quadrant either 1 or 4, because sine is negative. But in quadrant 1 and 4, your x values are positive. So, I don't know, let me just write it, quad 1 or quad 4. And then our x values are positive in those quadrant. So therefore, your a is going to be just positive 1. Okay, so we have A, B, and then R now. So now our point P, which is denoted by A comma B, this is going to be either 1 comma negative square root of 3, or it can be 1 comma square root of 3. But we already know that theta is going to lie in quadrant 4. So in quad 4, x is positive, y is negative, so we should be looking at this point right here. But anyway, so let me draw a picture. Picture always helps me. Okay, so let me just go. Oops. Okay, so now let's jot down 1 comma negative square root of 3. So if this is 1, okay, I can do this. So this point right here, let's make that into negative square root of 3. And another value can be here. So this point right here will represent 1 comma positive square root of 3. Okay, but we already know that theta better lie in quadrant 4. So what we're looking for is the angle that's going from the initial side to the terminal side, which is 1 comma negative root 3. So basically we're looking for this angle right here. Okay, so do you see that our theta right there, if I call this one theta, our theta better be negative 60 degrees, which will be negative pi over 3. Therefore, our theta was sine inverse of negative root 3 over 2. So therefore, sine inverse of negative root 3 over 2 is negative pi over 3. So that's just another way to do it if you like to deal with A and B and R. I personally like the first method, but you can choose your favorite weapon. Oh my goodness. What just? Next topic is finding exact values of composite functions. So recall that f inverse of f of x equals to x for all x in the domain of f, and f of f inverse of x equals to x for all x in the domain of f inverse. So with that said, sine inverse of sine of x is going to equal to x only if x is between negative pi over 2 to pi over 2, and sine of sine inverse of x is going to be x only if x is between negative 1 and 1. You must memorize this one. Okay, so let's take a look at some examples. I'm going to call this one, this will be example number 2, I believe. So find the exact value. All right, so let's go with A. Oops, that's an A. Sine inverse of negative pi over 10. All right, so let's do this problem first. So first note that sine inverse of sine of x equals to x if x is between negative pi over 2 to pi over 2. All right, so negative pi over 10 is playing the role of our x. Okay, now is negative pi over 10 inside of negative pi over 2 to pi over 2? I believe so. So since negative pi over 10 is inside of negative pi over 2 to pi over 2, what's going to happen is sine inverse of sine of negative pi over 10 is just going to become negative pi over 10. Okay, now let's take a look at this example. Part B, inverse of sine of 7 pi over 10. Okay, again note, I'm going to keep writing this till we all can memorize it. Sine inverse of sine of x equals to x, only if x is between negative pi over 2 to pi over 2. And let's just make a little star right here. Oh no, that's supposed to be a star. Okay, so first step, 7 pi over 10. Is it inside of negative pi over 2 to pi over 2? I don't think so, because look, let me see, where can I draw a picture? Let me just draw it right here. Okay, so 7 pi over 10, that just means what? From 0 to pi, divide 0 to pi into 10 equal pieces and take 7 of them. So if I divide this into 10 equal pieces, pretend that's equal length. Alright, so then what you need to do is take 7 of them. 1, 2, 3, 4, 5, 6, 7. So this will be 7 pi over 10, and our angle, the angle x better lie between pi over 2 to negative, pi over 2. So it has to lie between here or here. Okay, so notice that 7 pi over 10 is not between negative pi over 2 to pi over 2. So let me write that out. 7 pi over 10 is not in 2 to pi over 2. So in this case, what we need to do is we need to find theta that's between negative pi over 2 to pi over 2 such that sine of theta equals sine of 7 pi over 10. Okay, so let me just write that out. We need to find theta that's between negative pi over 2 to pi over 2 such that, ST means such that, sine of that angle theta better equal to sine of 7 pi over 10. Basically, we're looking for a reference angle, that's all. Okay, so let's find out a reference angle. Now 7 pi over 10, I've already drawn here. So its reference angle should be over here. Okay, now the total has to equal to pi. The reference angle, let's just call this one theta, that's our reference angle. That's what? 3 pi over 10. So that is our reference angle. So that means by the reference angle theorem, what we just find out is this. So therefore, sine of 7 pi over 10 is sine of 3 pi over 10. Okay, now we need to check if 3 pi over 10 is inside of negative pi over 2 to pi over 2. In this case, I believe so, because if I take 3 pi over 10, look at the green grid that I drew. You're going to take the first 3 pieces of it, which lies in quadrant 1, which means that 3 pi over 10 is between negative pi over 2 to pi over 2. All right, but let me just spell everything out. Since 3 pi over 10 is inside of negative pi over 2 to pi over 2, we can apply the note, which is denoted by star above. All right, so therefore, punchline. Sine inverse of sine of 7 pi over 10. This is same thing as sine inverse of sine of 3 pi over 10. And this is going to give us 3 pi over 10 for the answer. Let me just box this one then. Okay, let's take a look at another example. Call this one C. Sine inverse of sine of negative 3 pi over 4. Okay, so again, let's make a note. Sine inverse of sine of x equals to x only if x is between negative pi over 2 to pi over 2. Okay, so now let's analyze negative 3 pi over 4. If you're not comfortable with radian measure, feel free to convert that into a degree measure. But negative 3 pi over 4 is not going to be inside of negative pi over 2 to pi over 2. Okay, so let me just write that out. So note that negative 3 pi over 4 is not in our desired interval. So the note cannot be applied. Now, if you don't see that negative 3 pi over 4 is not in negative pi over 2 to pi over 2, feel free to convert that into a degree measure. So let me just do that. Negative 3 pi over 4 is what? Negative 135 degrees. Okay, which is not in, so this notation means not inside of negative 90 degrees to 90 degrees, which is equivalent to negative pi over 2 to pi over 2. So what we need to do now is to find the reference angle for negative 3 pi over 4. Okay, so let me just draw the picture. Okay, now negative 3 pi over 4 be right here. Okay, now so now reference angle is from here to here, which will be negative pi over 4. So let me write reference angle. Okay, now is negative pi over 4, is it inside of negative pi half to pi half? Yes, I believe so. Let me spell everything out. The reference angle of negative 3 pi over 4 is negative pi over 4. And negative pi over 4 is inside of that interval, negative pi half to pi half. So therefore, our note, which is the little star, can be applied. All right, so let's just write down the answer. So therefore, sine inverse of sine of negative 3 pi over 4. This is exactly the same thing as sine inverse of sine of its reference angle, which is negative pi over 4. So our answer is going to be negative pi over 4. There we go. Okay, what the heck? I still have a little room down there, so let's do another one. So let's go with example D. Let me just switch it up a little bit. So let's take a look at sine inverse of 1/4. Okay, so notice that the argument of sine is now sine inverse. Okay, so let me just make a note. Okay, so sine inverse of x equals to x only if x is between negative 1 and 1. Okay, so I think this problem is pretty straightforward. Now since 1/4 is inside of negative 1 to 1, star can be applied. Okay, so therefore sine inverse of 1/4, that's just going to equal to 1/4. Now the next topic is the inverse cosine function. So we're basically going to do the same thing as what we just went over for the sine function. So please notice that y equals cosine of x is 1 to 1 on 0 to pi. So y equals cosine inverse of x only exists on 0 to pi. Okay, and then the graph below is the graph of cosine inverse of x. You can get these points by swapping the ordered pairs, the key points I should say, for y equals cosine of x. The key points were 0, 1. So for the cosine inverse, you're going to have to plot 1, 0. And instead of pi over 2, 0, you're going to have to plot 0, pi over 2, and so forth. So that will be the graph. So please memorize that y equals cosine inverse of x means x equals cosine of y, where x is between -1 and 1, and y is between 0 and pi. Okay, let's do some examples. Example 3, find the exact value. So let's go with A. Let's try cosine inverse of 1. Okay, so always start out with let theta be cosine inverse of 1. Then theta is an angle that is between 0 to pi. Okay, anyways, so this implies that cosine of theta is 1, and theta better be between 0 to pi. So there are many ways that you can determine this value, but let me just draw a picture real quick. Okay, so cosine is going to start from 1. Okay, so let's look at that. Now from 0 to pi, which will be from here to pi, cosine of theta is 1 at 0. I don't know if you can see that or not. So therefore, cosine of theta equals to 1 when theta is 0. I'm just determining this value by looking at the graph, but there are other ways you can do. So therefore, the cosine inverse of 1 is going to be 0. Okay, let's do another example. Cosine inverse of -√3/2. First step, let theta be what we're looking for. Since we're talking about the inverse cosine, theta is between 0 and a pi. So this implies that cosine of theta is -√3/2. Now there are a couple ways that you can go about this, but let me use the triangle method because I like that way better, but feel free to use A, B, and R. Anyway, so this is adjacent over hypotenuse. And so basically this is telling you that our triangle that we're interested in, adjacent side has length square root of 3, hypotenuse is 2. So if I draw that, adjacent side square root of 3, hypotenuse is 2, so that means this length is 1. Hopefully you have memorized the 30, 60, 90 triangle, but this is going to be 30 degrees, which is pi over 6, and this is going to be pi over 3. And our theta looks like it's going to be pi over 6. That will be the angle. So let me just draw the positive quadrant because you're given that cosine is negative. So first you need to determine where that angle is going to lie in which quadrant. So all students take calculus. Now notice that cosine of theta is negative in quadrant, which one is that? 2 and quadrant 3. But theta has to be between 0 and a pi. So here's 0, pi. So your theta better be in here somewhere. Now it cannot be in quadrant 1 because then cosine would be positive. So what's going to happen is that cosine is going to lie in quadrant 2. So let me just box this. Okay, so now let's find the reference angle. You already know that angle theta is going to be pi over 6. That tells you that your angle from here to here is going to be pi over 6 because theta must lie in quadrant 2. So let's compute the remaining angle, which is from here to here. So this portion can be determined by pi minus pi over 6, which is 5 pi over 6. So we got our reference angle. Let me just write every step out. So therefore, reference angle 2 pi over 6, which lies in quadrant 2, is 5 pi over 6. Okay, therefore, our answer, cosine inverse of negative root 3 over 2, this is going to be 5 pi over 6. Now the way I did it was to recognizing the fact that if the adjacent side is root 3, hypotenuse is 2, I've already memorized that triangle 30, 60, 90. Now if you forget, then you can always use this business as well. Oh, sorry, maybe I'll change the color a little bit. Okay, or you can just simply memorize this chart. I know I've drawn this chart before. So 30 degrees is pi over 6, 45, and then 60. And remember, everything is going to have the denominator of 2. Okay, now for the sine, it's going to start from 1. Square root of 1 is 1. Square root of 2, square root of 3. Now cosine goes backwards, so square root of 1 is 1. Square root of 2, square root of 3. Okay, so if you look at that, let's look at cosine of theta is negative root 3 over 2. So it looks like, if you look at the chart, you already know what the angle is going to be. So that means theta is going to be pi over 6, but you're still going to have to figure it out where that angle is going to lie in. So, oh, sorry, not pi over, what did I just say? Theta is pi over 6, sorry about that. Okay, so like I was saying, you still need to determine where the angle is going to lie in. And if you find out that cosine is negative in quadrant 2, because theta must be between 0 and a pi, all you have to do is, so this is quad 1, quad 2, quad 3, quad 4. All you have to do is do the same exact thing as what we just did. So pi over 6 is 30 degrees, so this is pi over 6. And its reference angle is going to be 5 pi over 6. So you'll still get the same answer. So this is just another way to do it. The next topic is finding exact values of composite functions. Please memorize cosine inverse of cosine of x equals to x, where x is between 0 and pi, and that's nothing but a domain of y equals cosine of x, where the cosine graph is 1 to 1, and cosine of cosine inverse of x equals to x for x is between negative 1 and 1. Okay, let's do some examples. Example 4, find the exact value. So let's first go with cosine inverse of cosine of 4 pi over 5. Okay, so let's make ourselves a note. Note that cosine inverse of cosine of x equals to x only if x is between 0 and a pi. So in this case, our x is 4 pi over 5, and I do believe that 4 pi over 5 is in the interval from 0 to pi. So let me spell everything out. Since 4 pi over 5 is inside of 0 to pi, so I think we can just apply the theorem above, the property I should say. So that means that cosine inverse of cosine of 4 pi over 5 equals 4 pi over 5. And there's your answer. Just as a side note, a lot of students ask me, how do you know 4 pi over 5 is between 0 and a pi? So one way to think of it is this. Think of 4 pi over 5 as 4/5 times the pi. So basically what you're doing is take 0 to pi, and then you want to chop this up into 5 equal pieces, and you're going to take 4 of them. So pretend these are all the equal length. Is that right? 1, 2, 3, one more. 4, 5. All right, so pretend that they're equally divided. So what you need to do is take 4 of them. So you go 1, 2, 3, 4. So this angle is 4 pi over 5. So it does lie between 0 and a pi. Anyways, let's look at the next example. So let's go with example B. How about cosine inverse of cosine of negative 5 pi over 3. Let's make ourselves a note again. Cosine inverse of cosine of x equals to x, only if x is between 0 and a pi. Okay, so our x in this case is negative 5 pi over 3. And I believe that x equals negative 5 pi over 3 is definitely not inside of, that's the notation, is not inside of 0 to pi. So what we need to do is we need to come up with a reference angle for negative 5 pi over 3. So let's draw a picture. Okay. Now negative 5 pi over 3, remember pi over 3 is 60 degrees. Multiply that by 5, you're going to get 300 degrees. So negative 300 degrees would be maybe like this. Pretend that's a straight line, please. That's my terminal side. Okay, so here our theta is negative 5 pi over 3. Okay, so its reference angle is from here to here. Okay, so clearly our reference angle is pi over 3. Okay, now I'll write everything out. The reference angle for negative 5 pi over 3 is pi over 3, and pi over 3 is inside of 0 to pi. So we are good to go. So therefore, cosine inverse of cosine of negative 5 pi over 3, this is same thing as cosine inverse of cosine of pi over 3, which is going to give us the answer of pi over 3. So let me just box this whole thing. And there we have it. Let's take a look at another example. So let's call this one C. Let's try cosine of cosine inverse of negative 2/3. Okay, let's make ourselves a note. Note that cosine of cosine inverse of x equals to x if x is between, in this case, negative 1 to 1. Okay, so now our x is negative 2/3. Now I believe that negative 2/3 is inside of negative 1 to 1. So since x equals negative 2/3 is inside of negative 1 to 1, we can apply the property cosine inverse of negative 2/3 is going to be just negative 2/3. That one was pretty straightforward and easy. Okay, let's take a look at another one. The cosine inverse of cosine of negative 2 pi over 3. Again, I'm going to make a note. I'm going to keep writing this until you become familiar with it. So in this case, our x is negative 2 pi over 3, and that is certainly not inside of the interval from 0 to pi. So in that case, what we need to do is we need to come up with the reference angle. So let me draw a picture again. Okay, so negative 2 pi over 3. Okay, so it looks like our reference angle is going to become pi over 3. And pi over 3 is in fact in between 0 and a pi. So let me just spell everything out. The reference angle for negative 2 pi over 3 is pi over 3. And pi over 3 is inside of 0 to pi. So we are good to go. We can apply the property now. So therefore, cosine inverse of cosine of negative 2 pi over 3. This is cosine inverse of cosine of pi over 3. Now cosine of pi over 3, cosine inverse cosine of pi over 3, that's going to give us just pi over 3. So let me just box this whole thing. Oh, sorry. And that's our answer. Next topic is the inverse tangent function. So I've already drew a graph there, y equals tan of x. And y equals tan of x is 1 to 1 on the interval from negative pi over 2 to pi over 2. Certainly it is 1 to 1 from pi over 2 to 3 pi over 2, but again, we're going to take the interval that is closest to the origin. Okay, so since tan of x is 1 to 1 on that interval, tangent inverse of x exists on negative pi over 2 to pi over 2. So please note that y equals tan of x, where x is between negative pi half to pi half, and the range, which is all the y values, are set of all real numbers. So how do you write that? Is negative infinity less than y less than infinity. Now for y equals tangent inverse of x, you take that y equals tan of x and reflect that graph along the line y equals to x, and y equals tan inverse of x graph looks like the second picture that's on this note. Now for y equals tan inverse of x, the domain is all real numbers, and y values are between negative pi over 2 to pi over 2. So please note that y equals tan inverse of x means x equals tan of y, where x is all real numbers and set of all y values are between negative pi half to pi half. Please memorize that. Let's do some examples. Example 5, find the exact value. What I did above under the note, I just wrote down all the values for tan of theta, given theta between negative pi half to pi half. So if you can memorize that, that's fine, but there are other ways to do this without memorizing it. So anyways, let's do part A. Tangent inverse of negative 1. So start off, let theta be what we're looking for. And theta better be between open negative pi half to pi half, because at negative pi half to pi half, tangent graph has a vertical asymptotes there. All right, so this implies that tan of theta equals -1. Now, if you know that chart, do you see that tangent of theta is -1 when theta equals -pi/4? So our answer is going to be -pi/4. Let me just write everything out. So we discover that theta must be -pi/4, and notice that -pi/4 is in fact between -pi/2 to pi/2. So therefore, tangent inverse of -1 is -pi/4. That's going to be our answer. Now, if you don't like this method, there's another way to do it, is if you have memorized the graph and key points for y equals tan of x. Let me see, hold on. Now, I'm not quite sure if you remember this or not, but at pi/4 and -pi/4, our y value here is going to be 1, and then our value here is going to be -1. So that should tell you that tan of theta equals to -1 when theta is -pi/4. That's just another way to do it as well. So that was this point right here. Let's take a look at the next example. So I'm going to call this one B. Tangent inverse of √3/3. We're going to start off, let theta be tangent inverse of √3/3. And our theta must be between -pi/2 to pi/2. So this implies that tan of theta is √3/3. So one way to do it is by using the chart above. Notice that when theta equals +pi/6, our tangent of theta gives √3/3. So that means our theta must be pi/6. And that's going to be our answer. Now, in case you did not memorize the chart above, you can always use the triangle if you like, or A, B, and R. But anyways, I prefer using a triangle, but please choose your favorite weapon. So please note that √3/3, that's a rationalized version for 1/√3. Because if I have 1/√3, how do you rationalize it? Is multiply the top and the bottom by √3. So here you're going to have √3/3. So they're equivalent. All right, now tangent is opposite over adjacent. So I'm going to draw that picture out. So let me just erase this. Okay, so this is telling you the opposite side of our angle theta has length 1. Adjacent side must have length √3. Hopefully you realize this. This is our famous 30, 60, 90 degree triangle. So this is going to be our theta. And theta is 30 degrees, but theta is also pi/6. Now, since pi/6 is between -pi/2 to pi/2, we're good to go. So therefore, tangent inverse of √3/3 is going to be pi/6. Just for kicks, let's do another example. So I'm going to call this C, tangent inverse of √3. So start off. So which implies that tan of theta is square root of 3. Okay, so of course you can use the chart provided on the previous page, or you can just use a triangle. So let me try to do this by the triangle method. Alright, so square root of 3 is same thing as square root of 3 over 1. Now tangent was again opposite over the adjacent. So let me draw the picture accordingly. So this is telling you that opposite side of angle theta has square root of 3. Adjacent side must have length 1. Looks familiar? So hypotenuse 2. So our theta must be 60 degrees, which is pi over 3. And notice that theta equals pi over 3 is inside of negative pi over 2 to pi over 2. So we're good to go. So therefore, tangent inverse of square root of 3 is just pi over 3. Now, if I went too fast on any of these problems that we're doing, you can, of course, pause the video and go back, or you can look at my notes. I'm going to write all the detailed notes for what we went over, and then they will be posted in my lab math. So the next topic is composition of tangent and tangent inverse. So please memorize this property. Tangent inverse of tan of x equals to x if x is between negative pi over 2 to pi over 2, but it cannot equal to negative pi over 2 to pi over 2. And tan of tan inverse of x equals to x for x can be any real number. So that one is very nice, because it's telling you that no matter what kind of value of x that you're going to plug it in, your answer will be that value. Okay, example time. So example 6, find the exact value. Okay, so let's go with tangent inverse of tan of negative 3 pi over 8. Let's make ourselves a note. Tan inverse of tan of x equals to x if x is between negative pi over 2 to pi over 2. So our x is negative 3 pi over 8. Next step, you need to determine whether negative 3 pi over 8 is in fact inside of negative pi over 2 to pi over 2, in this case, which it is. If you don't see that, use the same trick as what we did earlier. So from negative pi over 2 to pi over 2, your angle must lie in here somewhere. Okay, so now let's just look at 3 pi over 8. That means you're going to divide from 0 to pi into 8 equal pieces, and you're going to take 3 of them. So let me see. Let me try to put this in 8 equal pieces. Pretend they are equally chopped. Now, negative 3 pi over 8 will be you take 3 of those. So negative 3 pi over 8 will be 1, 2, 3 right here. So this will be negative 3 pi over 8. And then it is, in fact, between negative pi over 2 to pi over 2. So the star holds. Let me write every step out. Since x equals negative 3 pi over 8 is inside of negative pi over 2 to pi over 2, we can apply the property. So therefore, tan inverse of tan of negative 3 pi over 8 equals negative 3 pi over 8. Let's look at another example. tan inverse of tan of 4 pi over 5. So again, let's make note. Again, I'm going to keep writing this until you become familiar with it. So in this case, our x is 4 pi over 5. Now, the step after that is you need to determine whether 4 pi over 5 is in fact between negative pi over 2 to pi over 2. I don't think so, because 4 pi over 5 should lie in quadrant 2. I'll draw you a picture in a minute. Okay, so let me try to chop this out into 5 equal pieces. Pretend that they're equal. And then 4 pi over 5, you take 4 of them, so this is 4 pi over 5, which is in quadrant 2, so that means which is not inside of negative pi over 2 to pi over 2. So since x equals 4 pi over 5 is not inside of negative pi over 2 to pi over 2, what we need to do is we're going to have to use the reference angle. Okay, so let's determine the reference angle. Notice that reference angle is going to be from here to here, which will be revolving this unclockwise. So this angle should be negative pi over 5. Okay, so let me just spell it out. Reference angle for 4 pi over 5 is negative pi over 5. Now notice that negative pi over 5 is inside of the interval negative pi over 2 to pi over 2. The way that I drew the picture on the left, negative pi over 5 is in quadrant 2, so it's not in between negative pi over 2 to pi over 2, but remember how to compute the reference angle. Reference angle, you're always going to start out from the initial side. Let me change the color here. Initial side, and then you're going to revolve negative pi over 4 units from there. So okay, so that will be negative pi over 5, and it is between negative pi over 2 to pi over 2. So we're good to go. So therefore, tan inverse of tan of 4 pi over 5 equals tan inverse of tan of its reference angle. And since negative pi over 5 is inside of negative pi over 2 to pi over 2, our answer is going to be negative pi over 5. I think I forgot to write, let me just insert this. Negative pi over 5 is inside of negative pi over 2 to pi over 2. Sorry, this note is looking really ugly, but I'll make sure to write a prettier version of it and I'll post it. Alright, so here's our answer for that example. Okay, let's do another one. Tan inverse of tan of negative 3 pi over 2. Now feel free to pause the video for now and just to see if you can do this problem or not. But so here's my note. So again, our x is going to become negative 3 pi over 2. And notice that x equals negative 3 pi over 2 is not inside of negative pi over 2 to pi over 2. So again, your next step is to come up with the reference angle for negative 3 pi over 2. So let me just draw you a picture where the negative 3 pi over 2 is going to be. So negative 3 pi over 2 will be from here to here. So its reference angle is pi over 2. So if we have to try to come up with the answer for this, it will be what? Tan inverse of tan of negative 3 pi over 2, which is gonna be equal to tan inverse of tan of pi over 2. Now do you see what's wrong here? Tangent of pi over 2. Remember, look at the tangent graph. So this is y equals tan of x. What's going on at pi over 2? Tan of pi over 2 is undefined because that tail end of the graph will never ever cross the vertical asymptote at x equals to pi over 2. So tan of pi over 2, this one's undefined. So tan inverse of tan of pi over 2 is undefined. So therefore, answer is going to be undefined. So that was a little tricky one maybe, but there you have it. I still have a little room down below, so let's do another one. D, let's try tan inverse of pi. Okay, so note tan inverse of x equals to x for all x values. So you can plug it in any value of x and your answer is always going to be that value. So in this case, our answer is just going to be pi. Maybe that was too boring, but I just wanted to go over this with you. Our next topic is to come up with the inverse function and finding the range of f and the domain and a range of f inverse of x. Okay, so let's follow the steps. Step 1, don't forget y equals f of x. So we're going to swap around x and y. So we're going to have x equals 2 tan of y minus 3. And don't forget to change the interval in terms of y as well. Okay, so now our job is to solve for y. So let's first bring the 3 on the other side. And I'm going to swap it around and write it this way. 2 tan of y equals x plus 3. Now dividing by 2 on both sides, what we're going to get here is tan of y equals x plus 3 over 2, where y is between negative pi over 2 to pi over 2. Now to solve for just the y, we need to get rid of that tangent function. So how do we do that is we're going to attack both sides by tangent inverse. So here what we're going to get is tangent inverse of tan of y equals tan inverse of x plus 3 over 2, where y is between negative pi over 2 and pi over 2. So this implies that we have y equals tan inverse of x plus 3 over 2 Alright, so since we're able to solve for y equals everything in terms of x, we can call this function f inverse of x. So therefore, this function now becomes f inverse of x equals tan inverse of x plus 3 over 2. Now remember, y became f inverse, right? So you need to replace this y with f inverse as well. Okay, so let me just box this. Alright, so notice that we need to find the range of f and then domain and a range of f inverse. So do you see that this portion here, let me just change up the color. Now this right here is nothing but the range of f inverse of x. So we have one problem solved, actually two problems solved. We got f inverse and the range of f inverse of x. So let me just write it. So the range of f inverse of x is precisely negative pi over 2 to pi over 2. Scroll back a little bit. Now notice over here, we already computed the range of f inverse to be right here at the very beginning. So I guess actually you didn't have to do that, but we did it anyways. Now let's try to find the range of f. Notice that our tangent graph looks just like the picture that's on the right. And for y equals tan of x, range is set of all real numbers. So range goes from negative infinity to infinity. So in order to find the range of f, first what we need to do is solve y equals 2 tan of x minus 3 for tangent of x, and using the fact that the range of tan of x is from negative infinity to infinity. Don't worry, I will write everything out. Okay, so let me just start off with to find the range of f. Solve y equals 2 tan of x minus 3 for tangent of x, and use the fact the range of tangent have to be between negative infinity and infinity. All right, so keep that in mind. So let's get to work. All right, so let's try to solve for tangent. We already did this earlier. So tan of x is that was y plus 3 over 2. And using this fact, let me see, this fact right here, we're gonna get what? Negative infinity less than tan of x less than infinity. But notice that tan of x is y plus 3 over 2. So we're gonna replace that. Okay, now our job is to solve for y from here, because y is going to be the range. So multiply both sides by what? 2? Not both sides, all of it by 2. So I'm going to multiply here by 2, 2, and 2. Now, negative infinity times 2 is going to give us still negative infinity. And infinity times 2 will just give you infinity back. Now, if I subtract 3 from that, negative infinity minus 3, we're still going to have negative infinity. Remember, negative infinity is not a number, but when you add negative 3 to negative infinity, your answer will still be negative infinity. And same argument for infinity minus 3 is still going to be infinity. So this is what we get so far. So what's going to happen is that the range of our function y equals 2 tan of x minus 3. It's just going to be all real numbers. So all right, now in a set notation, we could write this as range of f is set of all y values such that y is between negative infinity and infinity. So this means all real numbers. Now in terms of an interval notation, it's going to look like this. All right, so we got our range of f. Let me box that. The next thing we need to find is the domain and the range of f inverse. Okay, let's draw a picture of the domain and a range. So pretend that this is our domain for f of x. So f is going to go from here. So this is the domain of f. And the right hand side would be the range of f. Now remember, f inverse goes the other way around. So this is going to be of f inverse. So notice that the domain of f inverse is same thing as the range of f. So let me just write it. This is also the domain of f inverse. So these are equal to each other. Now also, domain of f is exactly the same thing as the range of f inverse. So these are the same. We're going to be using this relationship to find the domain and the range of f inverse. Okay, so first let's go with the domain of f inverse. So note that the domain of f inverse, this is same thing as the range of f. Now we just computed the range of f. So range of f, we just computed it right here. So the range of f was nothing but set of all real numbers. But we're talking about the domain of f inverse. So now domain is set of all x where the function is defined. So what you need to do is, instead of a y, you need to change that into a x because we're talking about the domain. So our answer here is going to be all real numbers, or you can write it as, set of all x values such that x is all real numbers. Or you can just simply just write the interval notation as well. Okay, so we're done with the domain of f inverse. Let me just box this whole thing. And again, at the very beginning, okay, so let's go back. Next is the range of f inverse. Alright, so the range of f inverse is nothing but the domain of f. Now remember, f, our domain of f was y equals 2 tan of x minus 3. Now remember this portion. X better be between negative pi halves to pi halves. So therefore, our range of f inverse, so let me just write therefore right here, and let's do the same thing. So therefore, the range of f inverse, now we're talking about the range of f inverse. Range is all set of all y values. So you can write this as set of all y values such that y is between negative pi over 2 and pi over 2. Or you can just simply write in terms of an interval notation, which is negative pi over 2 to pi over 2. So that's our answer. Let me just box this. And we're done. Okay, so for next example, let's look at the ugliest case scenario. So we're given f of x equals 2 cosine of 3x plus 2, and x is going to be between negative 2/3 and negative 2/3 plus pi over 3. So we're going to play the same game as part A. We're going to find f inverse, range of f, domain, and range of f inverse of x. So let's first go with find f inverse. Okay, so let's follow the steps. So step 1 was what? Interchange the role of x and a y. So again, y equals to f of x. Step 1, we're going to get x equals 2 cosine of 3y plus 2. Now don't forget to change the interval as well. Now next step, sorry, did I write step 1 and 2 and 3 in the previous example. If not, I apologize. So the next step is solve for y. So first, what should we do? Maybe divide both sides by 2. So what we're going to get is cosine of 3y plus 2 is x over 2. All right, now how can I solve for y? So first I need to get rid of that cosine. So attack both sides with cosine inverse. So this implies that cosine inverse of cosine of 3y plus 2 equals cosine inverse of x over 2, and so now that implies that, not 2y, sorry about that, it's 3y, is cosine inverse of x over 2. Now remember, we're trying to solve for y, so I'm just going to put dot dot. I don't feel like writing this every step. All right, so now how do I solve for y? Minus 2. Then we're going to get 3y equals cosine inverse of x over 2 and then minus 2. And then finally dividing by 3, we're going to get is y equals cosine inverse of x over 2 minus 2, whole thing dividing by 3. Now since we're able to solve for y equals everything in terms of x, this function y becomes our f inverse of x. And let me just write down. And y is f inverse of x, so I apologize. I need to make that into a f inverse of x as well. All right, so let me box that. Okay, so looks like we have the range of f inverse of x. So this is going to be our range of f inverse, which is same thing as negative 2/3, comma, negative 2/3 plus pi over 3. Okay, now next, let's find the range of f. Okay, so to find the range of f, we're gonna do pretty much the same thing as what we did in part A. So we need to solve y equals 2 cosine of 3x plus 2. Uh-oh, I'm running out of room. For cosine of 3x plus 2. We need to solve that for cosine of 3x plus 2. You'll see why in a minute. All right, so we can easily solve for cosine of 3x plus 2. So cosine of 3x plus 2, this is what, y over 2. Let me just box this. This is not our final answer, of course. Okay, now let's talk about this one. Note that, remember the cosine graph, right? Oops, why am I writing this in blue? All right, so the cosine graph starts at 1 and it is only 1 to 1 from 0 all the way up to pi. This is pi. And remember the range. The range is from -1 to 1. So pretend that this is our, not y-axis, sorry, u-axis or something like that. Instead of x, I'm just gonna call this u. Why am I keep writing that? All right, sorry. So this is gonna be u and this is gonna be y. So notice that this is y equals cosine of u. Okay, so now also note that cosine of u, the range of that is from -1 to 1. So okay, so now what we need to do is this. Pretend that your u is 3x plus 2. This is going to be our u. So cosine of 3x plus 2 is bounded above and below by -1 and 1 as well. So this implies that, oops, but the cosine of 3x plus 2 is y over 2. Do you see that? So cosine of 3x plus 2 equals to y over 2. So replace that with y over 2. And just solve, oh, what did I just put 2 there, sorry. And then from here, all you have to do is just solve for y. So of course, we're gonna have to multiply everything by 2. So it looks like you're gonna get -2 less than or equal to y less than or equal to 2. So this is nothing but the range of f of x. So let me just try to squeeze in the answer somewhere. So therefore, the range of f, you can just write your answer in terms of a interval notation if you like, or you can write it in set notation, set of all y such that -2 less than or equal to y less than or equal to 2. Most likely I'm going to ask you to express your answer in terms of an interval notation, but here is the range of f. So the next one is find the domain and the range of f inverse. Okay, I feel like my handwriting's getting worse. I'm sorry. I hope you can read my writing. But anyways, let's just draw the picture and see what's going on again. So our f is going to go this way. So that means what? This is going to be the domain of f and the range of f. Now the f inverse is going to go the other way around. So this is our f inverse. So this is the domain of f inverse. And this will be the range of f inverse. So again, you can see the relationship. Domain of f is same thing as the range of f inverse, and range of f is same thing as the domain of f inverse. Okay, so let's first go with the domain of f inverse. The domain of f inverse is same thing as the range of f. But range of f, we just computed that. So what was the range of f? That was what? -2 to 2. Okay, now if you want to express this in set notation, since we're talking about the domain now, here you're going to get soluble x, not the y now, soluble x such that -2 less than or equal to x less than or equal to 2. Okay, so let me box that. Now let's go with the range of f inverse of x. So again, note the relationship. So the range of f inverse is the same thing as the domain of f. Now domain of f is already given to you by the original problem, because remember the given interval? Given interval was what? -2/3 less than or equal to, was it x less than or equal to -2/3 plus pi over 3? So So let's recall that. So this is nothing but the domain of your function f of x. So here domain of f is going to be negative 2/3, comma, negative 2/3 plus pi over, is it pi over 3, right? Sorry about that. I don't know why I wrote 2 there. So that will be it. Now if you want to express this in a set notation, since we're talking about the range, now all you have to do is just change x to a y, suitable y such that y is between negative 2/3 and negative 2/3 plus pi over 3. And that's all. Let me just box this. Okay, so this will be probably the ugliest problem that you will see by finding the domain and a range of f inverse and so forth. If you have any questions, please let me know. Good job, you guys.